All right, guys, 4.3, we're talking about absolute extrema, and we're using a theorem called the mean value theorem. So, a lot of definitions for you to read through. I'm going to go through it pretty quick. Absolute maximum is the highest point on the function. Absolute minimum is the lowest point on the function, and it's usually a y value. A relative maximum is a little bit different than the absolute maximum because it just means that it's larger than the numbers around it. So for example, if this was my graph, I have a relative maximum right here and I have an absolute maximum at the top. So the red point is a relative and an absolute maximum. The black point is just a relative maximum because it's higher than the points around it. You get the same thing with relative minimums. Those happen when they are lower than the points around them, all right? Extrema are the max values or the minimum values, and critical numbers are where these happen, okay? Critical numbers are the x values where we get these maximums and minimums. And the nice thing about that is it's really easy to find those x values because at a maximum, I have a slope of 0. At a minimum, I have a slope of 0. So I can use the derivative to find where these happen. Sorry for the disruption. I'm sure they feel bad. So, extreme value theorem is it's a pretty standard theorem. It tells you that if there is a continuous function, then that means that we have a maximum and then we also have a minimum. Okay, we have extremes when we have a continuous function. There's going to be a highest and a lowest point on that function. All right, and we're gonna do some of these in an example here soon. So, examples. Use the figure of y equals f of x at the right to answer these questions. What is the absolute maximum of f? So when I look at this function, I am looking for the highest point, which happens to be this end point. And that value is 4. At what x value does f have an absolute maximum? Well, that absolute maximum, where'd my marker go? That absolute maximum happens when x equals -4. Okay, what is the absolute maximum point? Well, it's just that point, -4, 4. It's where the absolute maximum happens. So, 3 different answers to pretty much the same question. And it's going to be important on the AP test that you know which of these 3 questions you're answering, because they all come from the same point on the graph, but the answer is going to vary depending on what it's asking for. The absolute minimum of f is the lowest point on my graph, which is going to be down here. So my absolute minimum is going to be -2. And does it have a relative minimum? Yeah, it does. We've got relative minimums in a couple of different places. I've got a relative minimum right here. I've got a relative minimum right here. And I also have, this is weird, but this is a relative minimum because it's lower than the points around it. So at x equals -3, at x equals 1, and at x equals 2, are my x values for my relative minimums. My relative maximums happen right here. I have a relative maximum, and that's my only one. My end point is not a relative maximum, so I wouldn't consider that end point at -4. So at x equals -1, I have a relative maximum. Okay, here's how we find these things. All right, find the global extrema. So it wants me to find the maximum and the minimum of f of x equals 1/3 x cubed minus 2x squared on this interval. So to find extremes, I have to use the first derivative. So f prime of x equals, this is going to be x squared minus 4x. And to find where these happen, I set that derivative equal to 0 and I look for those x values. So 0 equals x multiplied by x minus 4. So 0 equals x times x minus 2 times x plus 2. Oh no, I'm not. That's just, never mind. That's not x squared. That's just x minus 4. So this happens at x equals 0, and this happens at x equals 4. Those are called my critical numbers. X equals 0, x equals 4. This is where I could possibly have my absolute maximum and my absolute minimum. This is where those could happen. But they could also happen at the endpoints. So if I'm looking for absolutes, I also need to check -1, and I need to check 3. Now what I'm going to do is just plug these in. I'm going to plug these into my function, and I'm just going to look to see which one is the biggest. So I'm going to plug in a 0. So f of 0 is going to equal what? 0 minus 0. So f of 0 is going to be 0. F of 4 is going to be what? 4 cubed. So that's 64 divided by 3 minus 2 times 4 squared. So I've got 64 thirds minus 32. So 64 thirds minus 32. I'm sure that's some number. You can plug it in your calculator. X equals -1. So f of -1. When I plug in a -1, I end up with what? -1/3 minus, minus 2. I was right the first time. -1/3 minus 2. And then f of 3 is going to equal 3 cubed is 27 divided by 3 is 9 minus 2 times 9 is 18. So that's going to be -9. So I look at these numbers and I look for the biggest number. I look for the smallest number. This one is definitely, whoa, what just happened? Don't do that. 64 thirds minus 32. If I want to clean that up a little bit, we've got to do 64 thirds minus 96 thirds, which is going to be -30. Did I do my math right? -32 thirds? Yeah. So -32 thirds, which is like what? Negative a little bit more than -10, which is smaller than 0. -1/3 minus 2 is just -2 1/3. And then I've got -9. So f of 4, this is going to be where my maximum happens, or my minimum, sorry. That's going to be my minimum. So I'm going to have a minimum of -32 thirds, and I'm going to have a maximum. My biggest value is just 0. Everything else was negatives, right? Okay, number 8, find the absolute maximum and minimum values of this function on the interval from 0 to 5. All right, so f prime of x is going to equal, man, do we want to do this the easy way? Because I know what x minus 2 looks like. We've got to do this the easy way. The absolute value function is a v. And x minus 2 just means that my v is shifted to the right 2. So when I look at this function, from 0 to 2, it's getting small. And then from 2 to 5, 3, 4, 5, it's going to get bigger. So my biggest point is going to happen right here at 5. So f of 5 is going to give me my biggest point, which is the absolute value of 5 minus 2, which equals 3. My minimum is going to be right here, which is just 0. So f of 2 equals 0, and that's going to be, this is going to be my max, this is going to be my min. I don't even need calculus to do that one because it's a really easy function to graph. Number 9 wants me to find the extrema of f of x equals 3x to the 2/3 minus 2x from -1 to 3. So same process, f prime of x equals 3 times 2/3 is going to be 2x to the negative 1/3 minus 2. So f prime of x equals 2 over the cube root of x minus 2. So if I want that to equal 0, 2 over the cube root of x minus 2, I'm going to add 2. So 2 equals 2 over the cube root of x. In order to solve this, for these sides to be equal, that would mean this 2 has to be over a 1. So that means that cube root of x has to equal 1. So that means x has to equal 1. That is my only critical number. But I can't just check my critical numbers. I also have to check my endpoint. So I'm also going to check negative 1, and I'm also going to check 3. So f of 1, 1 to the 2/3 is 1. So I get 3 minus 2, which is just 1. F of negative 1, negative 1 to the 2/3. That's negative 1 squared, which is positive 1. And then I cube root it, which is still positive 1. So I end up with 3 plus 2. So that one ends up being 5. F of 3, 3 raised to the 2/3 is going to be the cube root. So I'm going to get, what, 3 cube roots of 9 minus 6. And whatever, let's see, cube root of 9, am I doing my math right? Yeah, we're doing our math okay. So this is definitely going to be my maximum, right? So the question is 3 cube root of 9 minus 6, is that going to be smaller than 1? If cube root of 9 is bigger than 2, it's definitely going to be smaller. So you can go ahead, and this is one, I don't think they would expect you to know that one. That's going to be our maximum. I don't think that's one that they're going to expect you to do in your head. This would be kind of a calculator question. But if you're curious about this, cube root of 9 is hard to do. Cube root of 8 is really easy. The cube root of 8 is 2, which means the cube root of 9 is a little bit bigger, which means cube root of 9 times 3 is a little bit bigger than 6. So when I minus 6, I'm going to be in between 0 and 1. So this is going to probably end up, I erased it again. This is going to probably end up being my minimum. Okay. All right. Number 10. I know this is dragging on. Lots of examples. You can fast forward when you need to. It's not fun to watch other people do algebra, right? Find the global max and min. So I'm going to take my g prime of x, and that's going to equal 2 cosines of x. And then I'm going to add 2 sines of 2x. And I'm going from 0 to 2 pi. So if I set this equal to 0, 2 cosine of x plus 2 sine of 2x, we're going to go ahead and get rid of the 2's. We're going to divide everything by 2. So I end up with 0 equals cosine of x plus the sine of 2x. So cosine of x equals negative sine of 2x. So I'm looking for somewhere on the unit circle. I'm looking for somewhere on the unit circle that my cosine value is the opposite of double the sine value, right? I'm looking for anywhere that the cosine value is the opposite, and it needs to be twice as big. Or we can use that sine of 2x. This one actually might be easier if we use the double angle formula, which is something theoretically that you should know. But the sine of 2x, let's see if I still have this in here. Where are we? Trig, double angle for sine. And this should give us the formula that, we've all memorized so much, right? No, I haven't even memorized it. So double angle for sine is 2 sine theta cosine theta. So this becomes cosine of x plus 2 sine of x cosine of x, which means I can factor out a cosine of x, and I'm left with 1 plus 2 sines. So in order to make this equal 0, what x value makes my cosine, which is my x 0? That's going to be pi halves, and that's going to be 3 pi halves. And then I need 1 plus 2 sine of x to equal 0. So that means I need sine of x to equal negative 1/2. And if I look at my chart, what my sine, my y value is going to be negative 1/2 at what? 5 pi 6? And nope, that's going to be positive 1/2. It's going to be 7 pi 6, not 5 pi 6, because we got to be below. So we need 7 pi 6, and then we also need 11 pi 6. Those are where my values could be, but they could also be at my endpoints. They could also be at 0. They could also be at 2 pi. So all you need to do is plug in all of these values into G and figure out which one is the biggest, which one is the smallest. And we're not going to take the time to do that. You can plug that in your calculator, pick the biggest, pick the smallest, and move on. Okay, mean value theorem. Ignore all these notes. Here's what I need you to understand about the mean value theorem. The mean value theorem says that if your average value, like if I go from point A to point B, the average slope between those 2 points, if this is continuous, if I don't have any discontinuities, and if it's differentiable all the way across, then whatever that average slope is, at some point along that graph, whatever the graph happens to be, at some point I have to equal that slope. Okay, that's what the mean value theorem says. So basically, the mean value theorem says that let's see, how did we write it? Average rate of change is going to be equal to the instantaneous rate of change somewhere. So y2 minus y1 over x2 minus x1, where those are the endpoints, that is going to equal f prime of some value. It's going to equal the same thing. So what we do is we use this idea that the AROC is going to equal the instantaneous rate of change. So example 20 says, given that f of x equals 3 minus 6 over x, find all c values that satisfy the mean value theorem between 3 and 6. So the first thing I need to check is, what is my average rate of change? So I'm going to check f of 3, and I'm going to check f of 6. So f of 3 becomes 3 minus 2, which is 1. F of 6 becomes 3 minus 1, which is 2. So that means my average rate of change is 2 minus 1 divided by 6 minus 3, which is 1 over 3. So my average rate of change is 1/3, which means at some point my f prime is going to equal 1/3. Well, let's find out what f prime is. F prime of x equals we can rewrite, I don't want to rewrite it there. F of x we can rewrite. F of x we can rewrite to be 3 minus 6 over x, which becomes 3 minus 6 times x to the negative 1. So when I take the derivative, the negative 1 multiplies down and becomes a positive 6, and x goes down to negative 2, which equals 6 over x squared. All right? Now, I want this to equal 0. I want 6. No, I don't. I want 6 over x squared to equal 1/3. So I want to know where that's going to happen. So all I do is I solve for x. So I do the old railroad track thing. I times x squared. So 6 equals x squared over 3. I times by 6. So 18 equals x squared. So x is going to equal positive and negative square root of 18, which is equal to positive and negative what? 3 square root 3 root 2. So those are the two different places where my average rate of change equals my instantaneous rate of change. It's going to happen twice. It's going to happen at 3 root 2, and it's going to also happen at negative 3 root 2. Okay? All right. What else do you need to know? Oh, that's it for this homework. So homework questions. I think I need you to do all of them. Some of them we've already gone through with other students, so I apologize for all the stuff written in there. But 4.3, it's all yours. Good luck.